let us understand optical isomerism. It's a type of stereo or space isomerism. There are two types of space isomerism, optical and geometrical. So this is a type of stereo or space isomerism, and in order to understand optical isomerism we have to understand certain terms. The first term is unpolarized light. We will be able to understand the optical isomerism only when we understand these basic terms related to optical isomerism. So unpolarized light is, suppose this is the direction of propagation of light, and the ordinary light, unpolarized light is ordinary light, that is the natural light. So this light has vibrations in all the directions perpendicular to the plane in which light is propagating. This is the direction of propagation of light. So this direction perpendicular to this, there are various vibrations. You can see that I have made the vibrations 1, 2, 3, 4, and they are in all different directions, but they all are perpendicular to this direction of propagation. So unpolarized light is the ordinary light in which the direction of propagation perpendicular to the direction of propagation, there are vibrations in various planes. So if this is the light going in this direction, then if we observe the light, then there are various vibrations and they are in every possible direction perpendicular to this direction. Such a light is called unpolarized light. And second term is polarized light. If we take this unpolarized light and we pass it through a device called Nicol prism. So if this is the direction of propagation and this is unpolarized light, with which I am showing that vibrations are in all the directions perpendicular to the direction of light. So if this is unpolarized light, so Nicol prism, if the unpolarized light is passed through Nicol prism, then it becomes polarized. That means all the vibrations which were in different directions, they all will become parallel to each other, that is, they all will be aligned in one plane. So there were various directions, vibrations were in various directions, and now all vibrations have got aligned. So this is the alignment of the vibration, that is, all are now parallel to each other. So they all are arranged in one plane. This light in which all the vibrations are parallel to each other, or all the vibrations are in one plane, is called polarized light. And the conversion of unpolarized light to polarized light is called polarization. This process in which we are passing the unpolarized light through Nicol prism and it is getting converted into polarized light. This conversion is called polarization. And this device which is bringing about the polarization is called polarizer. That is, Nicol prism is a polarizer here, and the conversion of unpolarized to polarized light is called polarization. And unpolarized light is that light in which vibrations are in various planes perpendicular to the direction of propagation of light, and polarized light is that in which all the vibrations are aligned, they are in one plane. And polarized light can be obtained from the unpolarized light by the process called polarization. And we need a device called polarizer for bringing about this polarization. So in optical isomerism, we have to deal with polarized light and we have nothing to do with the unpolarized light, right? So polarized light is the main concern, which will relate to the further topic, optical activity. Now, after understanding these terms, let us understand optical activity. Now, suppose there are various vibrations, all are in one plane, but I am showing only one vibration. You will understand that this is not a single vibration. There are many such vibrations, but I am showing only one vibration. So, this is suppose polarized light where all the vibrations are in one plane. So, there are certain substances, organic compounds, if we take their solutions not in the solid form. Suppose there is an organic compound, so we have to take its solution. So solution of organic compound, if this polarized light is passed through the solution of certain organic compounds, then they have the ability to rotate the plane of the plane polarized light. You see, this was the original direction and now the plane is rotated towards right hand side, that is clockwise direction. Or it may rotate the plane of the plane polarized light towards left hand side. This was the original direction. Now it has rotated it towards left hand side. There are only two possibilities. Either the plane can be rotated towards right hand side or it can be rotated towards left hand side. So if there is an organic compound in the solution form, and if polarized light is passed through this solution of organic compound and this organic compound solution is capable of rotating its plane either towards right hand side or towards left hand side, then this organic compound is called optically active. Optically active are those organic compounds which have a capability of rotating the plane of the plane polarized light. This was the original plane and now they will either rotate it towards, suppose this is the plane, suppose this is the direction of vibration of plane polarized light. So this organic compound in the solution form will rotate it either towards right hand side, that is clockwise direction, or it will rotate it towards left hand side, that is in anti-clockwise direction. No matter in which direction it is rotating it, if it is capable of rotating the plane of the plane polarized light, the organic compound will be called optically active. And this tendency or you can say capability of rotating the plane is called optical activity. That is, this phenomenon or tendency in which the plane is getting rotated, this tendency or this capability of organic compound is called optical activity, and the organic compound is said to be optically active. On the other hand, there are certain organic compounds, if they are taken in the solution form, if we take the plane polarized light, even after passing through their solution, the direction of the plane is not changed. That is, this organic compound is unable to rotate the plane of the plane polarized light. So this organic compound is called optically inactive. So this is very simple to understand, that if the organic compound has a capability of rotating the plane either towards the right hand side or towards the left hand side, we call the organic compound optically active, and this phenomenon, tendency or capability is called optical activity. On the other hand, if there is an organic compound which is unable to rotate the plane. You can see it was in this direction, and even after passing through the organic compound, it remains in the same direction. That is, this organic compound is unable to rotate the plane of the plane polarized light. We call this organic compound as optically inactive. So, since we are talking of optical isomerism, we will be dealing with optically active compounds, that is those which can rotate the plane towards right hand side or towards left hand side. Now, what are the conditions to exhibit optical isomerism? That is, when will a compound exhibit optical isomerism, or when the optical isomers can be drawn? Like in geometrical isomers, we did certain conditions. In the same way, we will see that when will optical isomerism be shown by an organic compound and when it will be unable to show the optical isomerism. There are two conditions. First of all, a chiral carbon, which is also called asymmetric carbon, should be present. Now the question is, what is chiral or what is asymmetric carbon? Chiral or asymmetric carbon is a carbon which is connected to 4 different groups. See, optical isomerism, it is shown by saturated compounds only. That is, the carbon should form 4 single bonds. Geometrical is shown by double bonded compounds, and optical is shown by saturated. That is, you will have 4 single covalent bonds formed by each carbon. Now the condition is that this carbon should be attached to 4 different groups, A, B, X, Y. They all are different groups. Then this carbon will be called chiral carbon or asymmetric carbon, and we generally put a star, an asterisk sign over it to show that it is chiral. So whenever in any structure you find a star made over a carbon, that means that this carbon is chiral carbon, that is, it is attached to 4 different groups. For example, if this is the carbon and it is attached to hydrogen, hydroxyl, methyl, chlorine, so you can see that 4 different H, OH, methyl, Cl, all are different groups. Then this carbon will be known as chiral carbon, and we will show it by an asterisk sign. So this is the very first condition to exhibit optical isomerism, that carbon should be chiral. At least one chiral carbon should be present. At least one. You can have more than one also. So at least one chiral carbon should be present in the compound. That is, at least one carbon should be there which is attached to 4 different groups. So this is the first condition. And second condition, the second condition applies if there are 2 chiral carbon. If there are 2 chiral carbon in any compound, see, I said at least one, so there can be 2 also. So if there are 2 chiral carbon, then the plane of symmetry should be absent. Plane of symmetry should be absent. I will explain this point with the help of this example. For example, this is a chiral carbon which is connected to A, B and D, 3 groups, and here it is connected to A, B and D. See, this carbon is chiral. Why? Because it is connected to A, B, D and this whole group. So 4 different groups are attached. So this carbon is chiral, and this carbon is also chiral. Why? Because it is attached to B, A, D and this whole group. That is, 4 different groups are attached. So there are 2 chiral carbon. But if you divide the compound through this line, then this part and this part are exactly the same. This is symmetrical compound, that is, this is the plane of symmetry. Plane of symmetry is such a plane which divides the compound into two identical halves. जहाँ पे B है वहीं पे B है, जहाँ पे A है वहीं पे A है, जहाँ पे D है वहीं पे D है. That is, this is such a plane which is dividing the organic compound into two identical halves. Such a plane is called plane of symmetry, and if plane of symmetry is present, then organic compound will be optically inactive. That means it will not show optical isomerism. कब शो करेगा? जब ये plane of symmetry absent हो. For example, if the compound is like this, A, B and D, and in this part it is D, B and A. So if you divide it now through this plane, then B के सामने D आ रहा है और D के सामने B. That is, these two are not identical halves. Then this will exhibit optical isomerism. That is, I am saying that plane of symmetry should be absent. Means there should be no such plane which could divide the compound into two identical halves. If it is not dividing it into two identical halves, it is perfectly okay. You can have a plane which is not dividing. Now this is not identical as this, because B is facing D and D is facing B. So these are not identical halves, but these are identical halves. So if any plane of symmetry is present, then optical isomerism will not be shown, and this compound will very well show optical isomerism because plane of symmetry is absent. This plane is not dividing the compound into two identical halves. So these are the two conditions for exhibiting optical isomerism. First is chiral carbon should be present, at least one, or you may have more than one also. And second condition is applicable when there are two chiral carbon. If there are two chiral carbon, then plane of symmetry must be absent. So if these two conditions are followed, then only optical isomerism is exhibited. Now we will see the type. We saw the conditions of optical isomerism कि optical isomerism कब दिखाएगा compound, and we will now see the types of optical isomers. Like in geometrical isomer there were cis and trans. Here we have two isomers. One is called dextrorotatory or D or plus isomer. There are various ways of representing it. Dextrorotatory or small d. It should not be capital D. Even if you are starting the sentence, it has to be small d. Or you can represent it by plus sign written within bracket. So dextrorotatory or D or plus isomer is that isomer which rotates the plane. Suppose this is dextrorotatory, so it will rotate the plane towards right hand side. ये ओरिजिनल डायरेक्शन थी और ये राइट हैंड साइड में रोटेट कर दिया. सो इट रोटेट्स द प्लेन टुवर्ड्स राइट हैंड साइड और इन क्लॉकवाइज डायरेक्शन. Any such organic compound which can rotate the plane towards right hand side or in clockwise direction is said to be dextrorotatory. On the other hand, there are only two possibilities. Either it can rotate the plane towards right hand side or it can rotate the plane towards left hand side. Another is levorotatory or L or minus isomer. So minus has to be written within bracket. So levorotatory or a small l. So if the compound is a small l, that is levorotatory, then it will rotate the plane towards left hand side. This was the original direction of the plane. Now it is rotated towards left hand side, or you can say in anti-clockwise direction. So levorotatory or dextrorotatory, there are two types of optical isomers. Dextro will rotate the plane towards right hand side and levo will rotate the plane towards left hand side. This is all for this video. I am going to make another video for the further information on optical isomerism. Thank you.